So my name's James Goff, and I'm from the London Java community. I got involved with 3.10 about 18 months ago when I did a lightning talk on behalf of the LJC EC for the JCP group. So a lot of acronyms there. Java community process. We kind of have a program called Adopt JSR, and this was the first JSR that we adopted. And we pretty much used it as a pilot scheme to figure out how we would go about rolling out the Adopt JSR program globally. So my initial involvement was doing a lightning talk on this, and basically from there we got involved with myself and Richard on writing some of the TCK tests and then sort of moving TCK implementation tests and starting to separate those out. When we got to about 40-50% of the way through that, we kind of realized that there was still a lot of the API that was in flux. It was an active process in refining that. So we helped out with some of the design discussions and have met with Stephen many times over the last year. So we've held this off, and you can see that there aren't any slides because we want to give you guys an opportunity to ask questions, and we want it to be as interactive as possible. So we'll just go down the line and introduce everyone. Well, some of them don't need introduction, but Richard, do you want to introduce yourself?
My name's Richard, and Jim has said all the useful information that you need to know about me already.
Hi there, so I'm Stephen Colborne. I created Joda-Time and obviously have looked after JSR 3.10 a fair bit with other people around me keeping me sane along the way.
I'm Roger Riggs. I work for Oracle. I've spent a good bit of my past working on Java ME, but I've gotten involved in 3.10 to help get it into the JDK.
Cool. So about 11 hours ago now, we had a session on this, and I see a few familiar faces in the audience. So let's just start off by opening it up to any questions that people might have.
What are the remaining challenges in getting 3.10 in?
Well, there are a few. Obviously, we've got a number of open issues both in the sort of design and implementation. There's a bunch of implementation work that has been blocked by design issues. There's processes in OpenJDK that we need to sort of synchronize with, and so there's a little bit of extra work there. There are a couple of sort of larger design issues about the suitability and the usefulness of the APIs that we're going to hash out. And if you want to see all the issues, they're on the GitHub, so it's a pretty transparent operation. There's a fair amount of work to do. It'll be a bit of a challenge. I think the challenge is to get it done to fit into the milestone 6 in the OpenJDK schedule, which is sort of finishes at the end of January.
Does that answer your question, or do you any more information on that? Cool. Everything's good. Okay, any other questions from anyone on the floor? Okay, so I have some loaded questions. Stephen, could you tell us about some of the difficulties that we've seen with, I guess, providing a calendaring system which addresses the majority use case of people that use like ISO, from what we found out from some of the polls that we've run, that's the majority of users, versus also making sure that because we're, I guess, the JDK is used by people all over the world, how do we make sure that we still address international concerns as well as making sure we have a usable and logical system for most people?
I think the thing with the JSR like this, with the date and time thing, it's a question of how do you balance competing interests. We're also used to seeing the Java util calendar class, and do you write in your code Gregorian calendar equals new Gregorian calendar? Do you write in your code calendar equals new Gregorian calendar, or do you write calendar equals calendar.new instance? Those are kind of three different ways in which you could create your calendar objects. And each of those has different impacts, shall we say. If you do Gregorian calendar equals new Gregorian calendar, you're hard coding the fact that it's a Gregorian calendar. So the rest of your code can actually quite clearly work with that. If you do calendar dot equals new Gregorian calendar, it's a bit like you feel like you're using list equals new array list. So, yeah, kind of fine, but then if you pass that calendar object off to another method in another part of the system, that method actually doesn't know that you created a Gregorian calendar. I'll come back to that in a minute. And then you kind of have the last one, which is calendar equals calendar.newInstance. So, that's the way which is all localized and safe. So why does all this matter? Well, it matters because, the calendar system we use here, in Europe, in US, whatever, isn't the only calendar system in the world. If you go to Thailand, the year is different. If you go to Japan, they count years from the start of the emperor. If you go to, the different rules again if you go into the Islamic world or into the Hebrew world. Now, the chances are, if you write calendar equals calendar.newInstance, and you've got one, and you're in some other part of the world, you could potentially get one of these other calendar systems. And you kind of might think your application can deal with it, but perhaps it can't. The chances of you having tested your application with one of the other calendar systems is probably quite small. So there's a real tension between saying you want your application to be simply localized across the world and actually the implications of that. Because I'll give you a simple example. In the Coptic calendar system, there are 13 months of the year. And the first 12 months of the year have 30 days, and the last month of the year has 5 or 6 days. Now that has certain different things. Like if you think you're going to add a year to a date by adding 12 months, you're not. You might have made that assumption in your code because you were in your head thinking, well, obviously all years always have 12 months, but that's not the case in some other calendar system. So if you're just dealing with a Java util calendar object rather than Java util Gregorian calendar object, chances are you may well have made some wrong assumptions in your code. You won't have tested that. Depending on how you created it, you may end up with a bug in your code if you run your code in some other locale. So there can be some real subtleties around this. And so kind of coming back to where James started on this, it's like, to what degree do we balance the requirement for it to be easy to create and use calendar systems around the world against the requirement to, I'd like my code not to have bugs. I quite like the requirement of not having bugs.
A lot of this issues that you discussed has Joda-Time itself has addressed that, right? So, but my question would be like, your philosophy in designing the compromises or thinking about the issues, philosophically, has there been significant change from when you started Joda-Time to when you started with JSR 310, or even if the philosophy is the same, there has been changes that, the issues you have to have addressed differently just because it's part of the JVM and JDK has its own legacy issues, and that has changed how you approach the problem significantly. Has that been the case?
I think that the question here is basically, given Joda-Time, isn't it just the case you can take the things that were in Joda-Time and move them straight into the JDK? Because that seems like a fairly obvious thing. There are many people out there using Joda-Time. They're mostly pretty happy and they mostly don't have any problems. So I did write a blog post about this a whole fair old while ago, which is quite easy to Google, Joda-Time not 310, which I just did. So I kind of went through this kind of 4 basic reasons. So there are some design issues in Joda-Time. And, if you're just using it, perhaps you don't really notice them, because things just seem to make sense, and most of the time you don't tend to worry about those design issues. So kind of separation of the machine timeline versus the human timeline. We talked about this morning, that, machines are good at counting big numbers, humans want years, months, days, and they kind of get confused in Joda-Time. And the second one is pluggable calendar systems. And so this kind of alludes to what I've just talked about there. In Joda-Time, you have pluggable calendar systems. So if you have a datetime object or you have a local date object in Joda-Time, and you call the method getMonth, you might assume it returns 1 to 12. But as we discussed a moment ago, it might actually return 1 to 13. But it's such a, so technically in Joda-Time, the correct way to use Joda-Time is every time you make a method call, you should pre-check to see that it's the ISO chronology in there. Nobody does this. It's just not a feasible way to be dealing with date and time. For every time you pass one of the Joda-Time objects into a method, the first thing you should do is check to see actually it's an ISO one. That's crazy. It's basically a design flaw that kind of, when you actually think about it afterwards, kind of makes sense. The third example which I gave of Joda-Time, which is wrong, is null handling. In Joda-Time, if you pass null into anything, it always just accepts it. So if you pass null into a thing that's meant to accept a date or a time, it just uses the current time. So if you do the period between null and null, it's the period between now and now, which might be 0 or it might be a fraction of a millisecond, just depending on how the clock chooses to do it. This is generally just a bad idea. That one's easy to fix. That wouldn't have been a huge problem. But the final one is the internal implementation. Joda-Time's internal implementation. You guys don't know this, but actually it's kind of unmaintainable. Okay? That's the dirty secret of Joda-Time. There are plenty of issues that have come along that just mean it's really, the way in which it handles daylight savings time, the way in which it handles time zones, make it really difficult. Handling of the gaps and overlaps between the different timelines is really, really difficult, and it's just not possible to say it has this behavior in this case and it has this behavior in this case and it's reliably going to give you this result. I've had things where it'll return you one thing in the eastern hemisphere and one in the western hemisphere. It's that kind of unreliable behavior that's, I've tried pinning it down, it's not easy to pin down. So it's the learning of all of that feeds into JSR 310. But that means JSR 310 ends up looking quite different in certain ways. But if you like, JSR 310, I would say it's inspired by. It takes the learnings of, rather than being any kind of immediate derivation. So, does that answer what you were asking?
Cool. So a question for Richard. For general Java developers that are using the current date and calendar systems, could you kind of give us a brief overview of the new things that we should expect and we'll be using on a day-to-day basis once Java 8's out?
I think the thing to bear in mind is that the whole approach to the way dates and times are represented in 3.10 is significantly different to the previous existing implementations in Java. Specifically, a lot of common use cases and common concepts are explicitly modeled right down to the idea of having combinations of a month and a day for birthdays and all sorts of things like that, which are just not really there, and you kind of have to, as mentioned before, use zeros for certain fields, which has unreliable behavior with existing JDK classes. So I think probably the biggest change for people would be that when they're laying out the design of their application, they'll have to think about what specific class they wish to choose. Should this be a local date? Should it be a zoned date time? What's applicable for their specific scenario? And that's something which they may not have really had to deal with before, because they've just had these kind of does everything classes like calendar, where you just throw that around and play around with it however you want.
Cool. Are there any other questions on changes between, I guess, what we have now and versus Java 8 and 3.10?
Is there any way that the new stuff would have, sort of going back to testing, sort of talking about new stuff in general, but with the recent second bug that lots of people, would the new stuff have encouraged testing that in any way or pre-fixing that somehow?
Not really. I suppose that's the answer, isn't it? It's
Right. So, so we've talked about this, that the JSR 3.10 API, as we sort of mentioned this morning, has kind of a more seamless model of time and to try to keep those discontinuities from showing up in the API. But when we sort of examined that, leap second problem, and Stephen looked into it pretty deeply, the discontinuity in time actually, Java gets it from the operating system. The operating system gets it from NTP, and it goes pretty deep. So even the technique, which is sort of advertised in 3.10 of smoothing out the leap second over, 1,000 seconds before and after, requires some part of the system to actually accurately do that. And if Java doesn't know whether the operating system does that, or the operating system doesn't know that in the NTP server is going to reliably do it, you really can't, at the top level application, you can't guarantee that that's the behavior.
Yeah, it turns out NTP does actually have, so this is a network time protocol, it does actually have the information, it can accurately send out the information that a leap second is about to happen, is happening, and kind of has happened. The trouble is that somebody's done some research, and it's like 10 to 20% of all the NTP servers in the world are sending out the wrong information all the time. Right? So this is so broken. It's like there's not that much we can do up at our level. And it's kind of like, I thought we would be able to, but the reality is you kind of have to say, meh.
You could look at coping behavior. At the Java level, you could look at the stream of time coming in from the lower level and say, oh, it looks like there was a discontinuity. After the fact, let me smooth it out. But then, because the Java view of time doesn't necessarily match the native view of time, if you're talking between two, a native task and a Java task, now they have a gap or a skew in time, and that can cause a series of problems. Or if you're talking to another server somewhere else, and your time, there are skews that are actually better adapted between servers than there are locally, but it's really better to solve the problem way back at the source and not have to try to patch around it at the intermediate layers.
I was going to ask, I think Douglas had some comments on this issue before on the mailing list about what you thought of the definition of time in 3.10.
Douglas, can you use the microphone just so that
well, if I saw people moving up close so they can hear me. I also talk loud.
This is for the archive.
I'm Douglas Serber. I'm a member of the expert group. I do JDBC. Back when this whole process first started, one of the things I was very concerned about is how this API was going to handle leap seconds. And there's really three choices. You either have a non-SI second, where seconds vary in length. That's the choice that we've made for 3.10. You vary your epoch, because if all your seconds are SI seconds and you ignore leap seconds, then your epoch is shifting on every leap second. So that's a possibility. And the third choice is you model leap seconds. So, that's what you can do. And what was the question? What was my, about
what was your input?
My input on how we should be handling leap seconds. I think that the smooth leap second is a fine thing at a high level of the system. But ultimately, it's all based off of UTC, or if you want to go below that, the TAI or GSM, GPS time. And UTC has leap seconds. So something in the system somewhere has to know about leap seconds and handle them. And there has to be a clear contract between the different layers as to what's happening to leap seconds. We can't ignore them. And that's what's been a problem for 30 years, is computers, everyone is just kind of, it's ugly, and ignored it. And you can't do that. You get wrong answers.
Everything's fine for a while. You just reboot the system, and then it doesn't bite you again for a long time.
Or you wait for the Americans to get rid of leap seconds, which is what they've been trying to do for the past 10 years.
I think I have not heard anything that's moving forward. Maybe you are hearing something that I'm not. But
well, it went to the big vote thing at the beginning of this year, and they kind of said, oh, we're not going to vote on it.
Yeah.
So it's gone back to working committee for another 3 or 4 years, basically. So, but that's part of the problem. Yeah, we don't know whether leap second will exist in 10 years' time.
Well, how many of you really know why we have leap seconds? Most of you? Okay. The Earth spins, and a day is from when the sun is directly overhead somewhere to where it's directly overhead again. The rate at which the Earth spins varies. It's not 86,400 SI seconds. It's actually slightly longer than that, and it's changing. So time is convenient for everything to be an SI second. And so if all your clocks tick at SI seconds, which is the same speed all the time every day, that's really convenient. But if you do that, over time, the sun moves in the sky relative to noon, and that's confusing too. So leap seconds are inserted in order to keep 12 o'clock noon, the sun is directly overhead. And if you don't do that, then the sun actually is further and further to the east at noon.
One point is I think it only slows down, not just varies, right?
No,
It does vary a little
varies.
bit.
It varies.
Yeah.
Cluster?
Yeah, it goes up, down, up, down.
You know, we're talking tiny, tiny amounts, but they add up. And exactly that. The clock system is designed to allow negative leap seconds, where instead of you go 50 or 57, 58, 6 or 1, you will start the next one. So instead of going 58, 59, 60, 1, it goes 58, 59. What's your next question? Anyway, you get it. You understand it. Even if I can't say it.
Wouldn't it be easier just to occasionally have everyone jump to the west one?
Well, it's actually the suggestion. We have these hours, we have these days, all kinds of crazy stuff. But ultimately, if you want the sun to be more or less overhead at noon, you got to do something.
One of the bigger trouble handling dates, I mean, first two problems I face. The first one is that the Java date didn't used to have time zone information into the date, which caused all sorts of problems for everyone. The second thing is the database representations generally don't handle that too well. So, but when I thought we had with Java was that it just had one date, and JDBC only handled that one date, and basically nobody really thought about that until they have multiple times in their applications. So now you have this all sorts of date that's no longer in just Zora date. I mean, the way we used to handle it is that you have Zora date, do all the calculations there. When you save it to JDBC, you go back to Java date and do something there. But now everyone is getting exposed to all these new dates, and they're going to start using them. Is there? I'm not sure. Is JDBC somehow addressing that?
Yes.
So Douglas,
Explain what your job is.
Would you use the microphone, please?
Oh, yes, sorry.
Your voice carries very well.
But I don't like standing behind the thing. I'm sorry. The JDBC expert group is absolutely dedicated to supporting JSR 310, and we are all the members of the JDBC expert group are going to find all the members of the 310 expert group if it doesn't make it into JDK 8. This is really important for us. Actually, the databases support the databases, and I'm talking ANSI SQL, supports date times really well. It's fairly precise what it means. You have date, time, and timestamp. They do not have time zone information, nor is there an implicit time zone. Java util date, if you read the Java doc, has an implicit UTC time zone, which is really, yeah.
Java util date?
Yes.
Java util has an implicit local time zone.
No, it actually says that the internal representation is UTC.
Well, I can kind of see what you mean, but yeah.
I'm not saying what I mean.
If you do the two string, if you do the two string,
Java
it's
doc.
local. If you look at the internals, it's
Anyway,
UTC.
so there is no explicit, there's no implicit time zone information on date or timestamp or time either. But ANSI SQL also defines timestamp with time zone. And so that's where you need to go. If you want to use a local date, then use ANSI SQL date. A local time, ANSI SQL time. A local date time, you use ANSI SQL timestamp. But if you want to use an offset date time, then you're going to be using timestamp with time zone because that is specified as an offset. Now, ANSI SQL does not specify a timestamp with a named time zone where you get into all of the daylight savings time rules. That's not in ANSI SQL. A lot of the vendors have some capability of supporting timestamps with named time zones. So if you're working with a database that does that, then you can use, assuming the vendor's driver supports it, you can use zone date time to do that. So it's all becomes well defined. Now, if you've got a database that's full of timestamps that you've been interpreting with some magic as being in some particular time zone, and then now you're going to start writing code, you're going to have to think about it. And this goes back to what Richard said. That's going to be the biggest transition of moving to 310 is in the past you just sling around date or in calendar and it does, you write a bunch of code and you get to a place where you want to do something and there's no thinking. You just use date or calendar, whichever one you're in the habit of using. But with 310, you're going to have to make a design decision. What is this chunk of data? What do I need to do with it? What information do I have? And that's going to slow you down. You're going to have to think more. Now, you're going to debug less, and that's a good thing, but it will be a difference.
Yeah.
Okay. Does anybody have any follow-up questions from that? Cool. So back to some of the loaded questions. Roger, could you talk a bit about integration, in a bit more detail about integration into Open JDK, and whether you feel that there might be any opportunity to use any of the new language features?
Well, we haven't looked at it extensively. But there are several new language features in JDK 8 that would have some potential. There's a construct being introduced as part of the Lambda project that allows default methods to be added to interfaces. And there's a potential there it's more of an implementation optimization where instead of putting code down in some classes, you could potentially use the default method to have the implementation be shared across, or the implementation of a method that has a consistent behavior across all the types be done in the superclass. More interesting, but potentially less useful. We've been looking at actually using Lambda expressions, or we haven't looked very deeply, but there's potential to use Lambda expressions in some places in the API. But it may not be that constructive. For example, one of the constructs in the API is called a date time adjuster. It's basically a single method class or function that can look at a date and time and modify it in some way. If you want the third Friday in September, you can write a function that does that. You pass it into a date time object, and the date time object calls it back, it reevaluates it, and it produces a new date time object. So it acts as a Lambda. But if you were thinking of using Lambda in that same context, you could potentially put a Lambda expression right there in the call to date time adjuster. But in almost every case, the expression that you put there would more efficiently be done just by saying, date time dot, with year x plus 5 or something. Just directly operating on a date time object. So I think we need to look at it some more, in more depth, but we haven't really found, sort of a killer application for Lambda in.
Yeah. Lambdas are good for passing off to other systems to process your code, but if it's just calling back immediately, it doesn't gain you a great deal. Right. So it's not obvious how Lambdas fit into the JDK, whereas default methods in interfaces and potentially method references, those are possibilities for...
I think, though, from the point of view of the API users, the immutable style of classes within 3.10 does fit a more functional style of programming, which is being encouraged by the whole move. So for people who are actually coding, even though they probably won't be using those features with 3.10, it would feel natural to use.
Well, I think this is the thing. I mean, it's like
more functional style.
Joda-Time and JSR 3.10, they're quite functionally sort of designed libraries. In terms of being immutable, in terms of the way the method calls hang together, that sort of a style. It's how do you fit immutability into Java is not always an easy question, and that's kind of what drops out. It's a different way of looking at it, shall we say.
Yeah, there is one other aspect of the implementation that we might look at. So there are sort of the primitives for a date object and a time object, and then there's a date time object and an offset date time object. But for example, when you add 1 second to a date time object, the implementation of the sort of the offset date time object dispatches to the date a combination of local date time object inside the offset date time object, which in turn redispatches to the time object, which then actually adds the second, which sounds a lot like a function application of a function to add a second that's just dispatched down to the right level where it's actually evaluated. I'm not sure lambdas actually would help with that, but at the moment it's all sort of explicitly coded in the implementation. So.
Yeah.
Question?
Yeah, so it sounds like there's still quite a lot to do, and so maybe it won't be Java 8. Is there any way to split this up so you can get some to Java 8, some to Java 9?
A lot of stuff, was descoped a whole while back. So there is no interval class. So Joda-Time has an interval class which has a start instant and an end instant. In the same way as you might have had a local date range from a start date to an end date. These are things which would be useful to business applications, but we don't have them, then they're kind of descoped. So in terms of the broad set of functionality that's in there, there's not really a whole lot you can take out without it just not really making much sense. Now, can we find bits we can take out? Probably. Will that save us? Maybe.
I mean,
confident are you that things will be done, in the next 3 months or so people can test this out as part of the JDBC?
Well, you're in a position today where you can go and download it from GitHub, and you can give feedback, and that's the thing that actually is kind of required in terms of us knowing whether it's something you find usable or not. So that's always been the case. It's always on GitHub. It's actually officially an early draft review at the moment, which is an official JCP stage where you're supposed to give your feedback for 30 days. Not that anybody really cares because it's always open, therefore it's always in early draft review. But hey, that's the way the game works. Roger?
So part of the integration steps is we've created a project within OpenJDK, obviously called 3.10, to stage the 3.10 source code into the OpenJDK sort of framework and builds. It's getting pretty close, but when we get that in, we'll be able to do sort of private builds of the sort of the collected OpenJDK, the thing that will go into OpenJDK, and we'll have to figure out how to whether we can make them available sort of regularly, like they do with the Lambda builds and the rest of the JDK. The JDK is built every day, every week for some download and use. November.
See, that's the part that starts to make you wonder whether.
Well, yes, I think there's quite a bit of risk here because I think there's a lot to do. I guess I would sort of thinking of alternatives and ways things we might be able to do. So there are sort of 5 packages within the datetime API. Basically, the core package which says Chrono. There's this low-level API which gives access to a lot of datetime functionality, and that one's pretty core. The Chrono package has the API for calendar neutral or regional calendars. There's a formatting package, sort of a complete formatting package. I could potentially see that we could fall back to using simple date formatter with all of its flaws if there was, for some reason, the formatting package couldn't, we couldn't see collective resources and finishing in time. And there's a separate time zone API that lets you get details out of the time zone database. Potentially, the time zone behavior that's built into all the APIs could be done without that exposing that explicit API. So, we will be talking about alternatives to try to reduce the risk and make sure that it gets into 310. There are a lot, as you know, I agree. It sounds risky, and it's not without some risk.
I think you also have to bear in mind the converse risk, in the sense that because you're going to need to maintain binary compatibility, so standardizing part of the API without being sure that the other parts are going to fit in with it imposes design constraints down the line, which you may realize that you wish you hadn't made. And you kind of already got two APIs, which are design decisions that you probably, with hindsight, wish you hadn't made. So best not to have a third API in that situation.
Just a note for anybody that's interested in a really quick way to try out what's available. If you go to GitHub and go to .jsr 310, there's a project called Time Machine in there. So what this is it's basically we ran a session in London, which was to get people from the local Java community to come in and actually try out the API. So what we have in here is basically 3 sets of failing unit tests. So the project loads straight up into Eclipse. You can give the API a once-over, and we'd obviously appreciate your feedback because it'll help us to improve what we have. So that's what this bottom link is. On top of that, I have another loaded question, which is probably more for my benefit. But Roger and Stephen, could you allude to what impact you think the Adopt JSR program has had in terms of this JSR?
Only allude? It's pretty loose. Actually, I think it's very beneficial. The 310. Actually, Steve, I should let Stephen talk about the history, but I think it's always beneficial to have sort of a broader view of the ongoing work. The contributions that the LJC has volunteered to make to contribute to writing code, writing tests, and validating the APIs that's one of the reasons we have the JCP and expert groups and the diverse involvement is to get different views and different contributions.
Well, yeah, I mean, from my perspective, I think it's kind of been essential. I've had a busy year. Time is always of an essence in everything we do. Having a 4-month-old child doesn't help you necessarily in being able to work on these things. So it's an essential aspect of bouncing ideas about getting work done. You need to have people working with you on something like this. You can't just do it on your own. So that's why I always, at events like this, I'm always saying, come and give your feedback, come and ask your questions, come and try it out, because, without that, it's just a limited people's opinions. The more opinions you have, the better.
Cool. Does anybody else have any other questions?
Yes, this goes to Douglas. As far as the JDBC APIs, what you're going to do with the method setters and getters, will you be introducing new ones for the new date and times, or are you going to change the meaning of the old ones?
We talked about that extensively at the JDBC standard session yesterday.
Sorry, I wasn't there.
So I'm not going to answer your question. No, we're tired of adding new methods for new types. Have you looked at JDBC 4.1 and JDK 7? So you've seen the generic get method. All right, so for those of you who aren't familiar, JDBC has got about 6,000 methods that are of the form get xxx, where x is some random Java type. We got tired of that. In JDBC 4.1, which is in JDK 7, we introduced a generic get object method. It takes a type argument, which is a class. So you say get object, which column in the result set you want, and then a class. And it will return an instance of that class, or it'll barf. So we are not going to add any more get xxx methods. So if you want a offset date time from your result set, you will say result set.getObject column 3, offset date time dot class. Okay, that's the getter. There is no setter in JDBC 4.1 because one of the vendors at the very last minute put the kibosh on the design and it didn't happen. So in 4.2, we're introducing a generic setter. Now, when you're getting a value from the database, you want a Java value. When you're putting something back, you want to put back SQL. So the argument to the generic setter is not a Java class. It is not exactly, but we'll skip a whole lot of details, an enum which specifies the SQL type that you want this thing to be. So you'll say prepared statement dot set object parameter index my offset date time ANSI types timestamp with time zone, and that says put this offset date time into the database with as a timestamp with time zone. So again, there will be a generic setter and update methods for updatable result sets.
So, but Douglas, even if you don't add a new API with a new type, don't you somewhere in the spec have to say you must support,
there is
these new date times?
The magic table B3 will list the new types. That's
okay.
Pretty much the only change is table B3 of the spec.
So we've got like a couple of minutes left, so if you do have a question or something that's burning on your mind, now's the time. James?
Okay, so was that a last minute question? Go for it.
No.
Okay, cool. So just a quick note on what people can still do to get involved. The project's on GitHub. There's a public issue list as well. So if you want to have a go at bits and pieces and actually see how this API works, that's still an option. Once we actually get the feature complete, there's going to be other opportunities to help completing the testing. There's also going to be opportunities for performance tests as well. So yeah, thank you very much for your time.